Hello, my name is Naveen Chauhan, and in this video, I will discuss about the channel allocation. So these are the contents. I will follow the channelization. I will tell you about the channelization and the type of channelization protocols, the frequency division multiple access, the time division multiple access, and code division multiple access. So channelization is, in this last video lecture, I have discussed about the random access protocols like the channel and the controlled access protocols. Now the third one is the channelization. So channelization is a multiple access method in which available bandwidth of a link is shared either in the form of the time, frequency, and through the code among the different stations. So obviously for any organization or enterprise, it's not possible to purchase multiple and different medium for each and every system. So they purchase only the one bandwidth or the spectrum which is shared among the multiple stations. So it means at the same time more than one station can utilize the same channel, same medium or carrier to access the internet. So now this single stations or channel is shared among multiple devices either in the form of the time. So it means the channel is divided. It can be shared in a time slots domain. The second is the frequency. It means it can be allocated in the piece of the some frequency. So it means the some part of the frequency will be allocated to for a 24/7 hours. However, for the third one is the code. In that case, the channel is not distributed either not in the form of the time and the frequency. Only all the stations are the free to transmit their frames at any moment of the time. It's more 24/7 hours, but their data are differentiated based on some different codes. So the three different types of the channelization protocol. The first is your FDMA, frequency division multiple access, then time division multiple access, and then CDMA, code division multiple access. So in frequency division multiple access, it means the complete frequency band is divided into that many numbers of stations. So let's suppose in my system or enterprise, the n number of stations are available. So the complete frequency band is divided into n numbers of slots. However, it's not feasible or theoretical. In practical, it's not exactly the one of the nth portion of the frequency is allocated to a particular stations, because there is a one such problem that is called the frequency overlapping. And most of this, for this example, you can see you heard about in a rainy season, the two FMs are collide. So the two songs are collide. That's the problem of the frequency overlapping. So to avoid this, they utilize the silence or the blank between any two frequency slots. So that's blank or this frequency gap is called the the guard bands. So that's why you can see from this figure, you can see in the middle of this portion of the figure, you can see there is some white space between any two color codes. So these color codes showing the different frequency band. Let's suppose a 20 megahertz bandwidth is allocated to a particular organization of a particular. So in that case, you can see if in my organization only, for example, I'm just taking the 4 stations. So 8 megahertz, the frequency band will be divided by 4. So it means the 2 megahertz, theoretically, the 2 megahertz will be allocated to one of the stations, but it's not exactly in practical, it is less than the 2 megahertz. So the available bandwidth is of the common channel is divided into the bands that are separated by the guard band. So you can see the complete bandwidth is available to one particular, so not exactly the complete, the one of the nth the portion of the total band is available for a one station for a 24/7 hours. So one of the best example is the FM. So in FM, the one of the channel, like suppose for 91.1 megahertz is allocated to one of the station company. Then next is the TDMA, time division multiple access. In that case, the complete channel frequency band is available for one of the station at one of the time. So now this the x-axis is divided based on the time slot. So one of the time slot is only will be given to one of the station, and now one of the station can transmit their data with the full speed or with the full bandwidth. Now it can utilize the complete bandwidth. So it means the x-axis, now on x-axis the time is divided based on the different time slots. The bandwidth is just a one channel, that is time shared among the different stations. Now you can see now they are divided onto the horizontal way. So now next is the CDMA, code division multiple access. So one channel carries all transmission simultaneously. It means the stations or the channels is not distributed among the station based on either the time or the frequency. It means the complete channel is available for all the station at the same time. Now, but their data will be differentiated based on some specific codes. Now you can see in this example, you can see this, there are the 4 stations, 1, 2, 3, 4, and they want to transmit some D1, D2 and D3 values. However, there are some C1, C2, C3 respective codes. These are the CDMA codes. And the concept is that the data will be multiplied by the code, and after that all these signals will be summarized and it will be transmitted through this channel. So now for understanding this example, you can see for this example, let's consider the C1, C2, C3 values are plus, plus, plus 1, plus 1, minus 1, plus 1 and minus 1, and these values are taken from with the help of the Walsh table, which will be discussed in the next few sub slides. Data representation: if any station wants to send the 1 bit, that will be considered as plus 1. If it wants to send 0 bit, that will be considered minus 1. If it does not want to send something, in that case that will be considered as a 0. Now to analyze this example, the sharing the channel on the media, let's suppose at T0 time the station wants sends to bit 0. Now according to the data sequence, 0 bit will be the minus 1. Station 2 wants to send bit 0, that will be the minus 1. It does not want to send something, so that will be considered 0. It means this is a D3, and D4 will be the plus 1. That's why, because it wants to send bit 1. Now this is the code which is coming from the Walsh table. So now I'm just multiplying this. So minus 1 plus 1, it will be minus 1, minus 1, minus 1. Again, once I minus 1 multiply by this C2 code, so that will be the minus 1 plus 1 minus 1 plus 1. Then again at the time later on, it will be, we will take the summation. So the value will be the minus 1, minus 3 and plus 1. Now this is the code, and that is showing the signal. What will be that will be the sent after the summation of all these values. So this is the signal. The digital signal created by the 4 stations in CDMA. Now you can see. Now let's suppose the station 3 wants to get the data which is coming from the station 2. So the same signal will be received by all the stations, but if the station 3 wants to receive the data from the station 2, so now it needs to take the inner product with the help of the station 2 code. So this is showing the station 2 code, plus 1, minus 1, plus 1, minus 1. Now I'm just taking the inner product. If this value is minus 1 and this value is plus 1, so that will minus 1 plus 1 multiply. So the multiplication will be minus 1. Now it is minus 1 and it is minus 1, so that will be the plus 1. Again, this is a minus 3 and this is plus 1, so that will be the minus 3. It is plus 1 and it is minus 1, so that will be the minus 1. Now if I'm taking the summation of this all the values, minus 1 plus 1, so that will be cancelled, minus 3 and minus 4, that will be the minus 4. The total summation is minus 4. Now there are the total number of stations are 4. So minus 1, minus 4, that is the summation of this signal, received signal at the at station 3 divided by the n value, that is the total number of stations, that is minus 1, and minus 1 was the bit number 0. So it means station 2 sends the bit 0 to the station 3. So this is the popular Walsh table. According to this, we have find out the number of the different codes for if there is only the one station, that the code will be the plus 1. If there is a 2 stations, that will be the W1, W1, W1. It means plus 1, plus 1, plus 1 and minus 1. So now you can see W2 will be the plus 1, plus 1, plus 1, minus 1. So the code, the station code will be based on the row wise. So plus 1, plus 1 and plus 1, minus 1. Now W4 will be the W1, 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 and that will be the opposite of negation of the W1. So if this is the W1, so plus 1 minus 1, so that will be taking the negation of this complete W. So this is the reference book where you can refer for more details about the channelizations. Thank you.